So if f of t equals 1 over t, what's the difference quotient? Well, I'm not going to drag it out, we don't have time, and you'll understand if you don't already. Well, it's f of t plus h minus f of t over h. Doesn't matter what the function is, that's your difference quotient, because it doesn't matter what this graph is, this thing gives you the slope on that interval from t to t plus h. And you could draw that because you know how to draw the 1 over t graph. Okay, well, f of t plus h is 1 over t plus h. And f of t is 1 over t, and you divide that by h. That's pretty simple, wasn't it? And I've asked you to do this, and I think most people did it okay. If not, I put a note in your paper, and hopefully you got it. Well, you can write this numerator as t over t times t plus h minus t plus h over t times t plus h, all that divided by h. And all I did was I put these over the common denominator, and you guys know how to do that. If you don't remember, fix that, because it won't take you 5 minutes, because people are pretty good with that. Okay? So this equals t minus the quantity t plus h over t times t plus h. Okay, no, I don't want to leave it there, it looks bad. Now I smudge it out so it looks even worse, but here we go. And just by the rules of algebra that we started the semester with, what's t minus the quantity t plus h? Well, do the algebra. Distribute through by the minus sign, you're going to have t minus h, so you have negative h. And that times 1 over h, of course you can arrange that then as the negative of h over h, which is like negative 1. So this equals negative 1 over t times t plus h. As h approaches 0, this approaches 1 over t squared, doesn't it? Negative 1 over t squared. Okay, none of this is horribly difficult to understand. So make sure you understand as much of it as you possibly can. It's just an exercise in algebra after you write this down. Okay? And it's an important exercise in algebra. Now another example, of course, if it was 1 over t squared, then you'd have 1 over t plus h quantity squared minus 1 over t squared, but you'd still do the same thing. You just end up with different power. And it'd be a little more complicated. I probably wouldn't ask you that, but maybe I would if I wanted to give you extra credit or something. Okay? First square root of okay? That's pretty simple. It's really simple if you think the square root of t plus h is the square root of t plus the square root of h, but I hope you know differently. Square root doesn't distribute over addition. Multiplication distributes over addition, not square rooting. Okay? Now this is a little trickier. So I might, if I put this on, just ask you to write out what the difference quotient is. And then maybe for an extra point or two, simplify it if you don't remember how. It's not hard to simplify, but you got to be pretty good with your algebra. The way you simplify this, it's worth seeing the algebra of it. It's kind of like what you do when you're dividing complex numbers, which some of you did pretty well on one of the problems I asked you to work on the review problems. It's a whole lot like multiplying by the complex conjugate, and if you don't remember what that is, fix that, look at this video again, or look at your notes. And remember, this is a lot like the complex conjugate. If you multiply this out, you get this, and that just comes down to h over h times the square root of t plus h minus the square root of t plus the square root of t. And then as h approaches 0, this h divides this one. Does this as h goes to 0. So this is a little trickier than this one. So maybe I'd be happy if you just wrote this down, the rest of it for extra. Okay? But you should understand the algebra of it, and that's the main point of my having gone through this. And the other main point is, if you do take a calculus course of any kind, you're going to have to do this, so you might as well see it now, kind of where you start. Okay? If you do this with any power function, it turns out what you get is a power function. Like, you started with a -1 power, right? And when you did all this, you ended up with a -2 power, didn't you? Here we started with a 1/2 power. What power did we end up with? It's -1/2 power. If you don't understand why that's a -1/2 power, ponder it. Because we've done it many times. Okay? And -1/2 is 1 less than 1/2, right? Subtract 1 from 1/2 to get -1/2. Got the 1/2 in the number line, go 1 unit over here, you're at -1/2, right? Okay? Understand all that. Okay? So, make sure you know how to plug in to the difference quotient, which is just a matter of how you substitute for the variable in definition of your function. Okay? In other words, function notation.